Hi everyone, my name is Denis and I will show you the tool that I built to find hidden man-made structures. So let me just show you how quickly we can run it. So I have a remote machine here without the tool installed. So we have a small script to install it. So it will clone our repo, install the UV package and environment manager for Python, and basically install all the dependencies. So we paste the code here. And let's wait. Okay, done. So now we go to our folder with cloned repo and let's open it. There is just an hour before the deadline, so it will be, I'll try to record this pretty quickly. So we have our pipeline configuration here, and what we need to do, we just need to specify the bounding box. Okay, so let me see. Okay, so I have prepared the the configuration. Let's use it. The only thing that I need to remove is this. No, because it's related to my personal local machine. So the path here is incorrect for this remote machine. Yeah. So it will run the sequential pipeline and will download all the data, Getty, Sentinel to other DEM surface like SRTM, AW3D. So it will also detect anomalies and use the ChatGPT O3 model to scan the generated images for any hidden man-made structures, and it will create the interactive map that we can see. So let's save and try to run it. So we do uv run python pipeline, and we specify the path to our config file. Okay, let's try. Okay, so now it downloads all the data. So right now it downloads the Copernicus DEM. Okay, it's failed to load the credentials. Okay, so we need to use credentials for downloading the Getty points. Okay, so let's add them. Okay, and because the Getty points are might be too heavy, it depends on the bounding box specified. If the bounding box is too big, it will take a lot of space, so it will ask you before downloading. So let's answer yes. Okay, and it will take a couple of minutes to download all the data. I'll probably crop this part later to speed up the process, to speed up the video if it will be too slow. Or maybe I can tell you maybe about myself. So my name is Denis. Currently I live in Spain. Originally I'm from Moldova, where I get my bachelor's degree in anthropology. But right now I am a software developer. Yeah, so this Kaggle competition is pretty exciting because like my skills and my old education is kind of intersected. Yes, yeah, I'll probably will not crop this part because it's almost done. Let's wait for a couple of seconds more. Also, it's almost the deadline, so this video is kind of will not be edited or fancy or whatever, just showing you how the pipeline worked, and I hope you will enjoy my write-up where I highlighted all my findings about the velocity of Z, some other sites, which is pretty exciting. Okay, so the SRTM DEM is also downloaded, AW3D DEM. So we have 3 DEMs from Copernicus, SRTM, and AW3D, and I found that AW3D is the most like the best in terms of the resolution, and I use it later where we compute the difference between the DEM and computed per Earth model from Getty points. And we download multiple DEMs because we can compare them to see if there are any artifacts in one of them. Okay, Sentinel imagery is fetching. So there we have all the canopy stress on the foliage of the ground, because if we get the good dates for the low stress and high stress, we can see on the images the patterns of the hidden structures. So for example, this date here, there were some forest fires in the Brazil or in Bolivia, and it was really it really highlighted the patterns, the hidden lines in some of the parts that I analyzed. Okay, so it's done. So the bare Earth surface is calculated, computed, and residual relief. Some NML is detected with some simple algorithms there. There is also an option to export the DEMs in the OBJ file, so we can view them in Blender. And the ChatGPT analysis, there where we pass all the images that we specify here to to the specified model, so all three here, and it will try to analyze and output the points with description of the anomalies. So the interactive map is created, so let's see, let's just download it. The cool thing about this is that we can simply download it, the HTML file, and view it, especially if the bounding box is not huge. The HTML will not take a lot of space. Okay, so yeah, this one. Yeah, there are some sliders here, so I just didn't have time to remove them. I had like opacity and transparency here, just ignore this. So here's our bounding box. We've highlighted red dots are anomalies that computed from the DEM difference, and these flags are the ChatGPT's output. So what it found here, so a nearly perfect circular platform, blah 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 blah. So, and you can check all the ChatGPT's points, their description here on the map, and then you can see the outputs of our tool. So residual relief, it highlights this blue part. There is a negative difference here. So blue is like the bare earth constructed from Getty points is lower than the DEM of the defined model AW3D here. We can see that the bare earth is, so obviously the Getty points are pretty sparse, and it does not get this spike here, which is present in AW3D and SRTM and Copernicus. We can also check the stress images of this is the stress difference of the low season stress and high season stress images of KNDVI. The same for NDMI. So that's the low season, low stress season, high stress season difference, and by analyzing these images we can get some insights of what happens there. Plus the ChatGPT gives us clues about anything that it highlights. Yeah. So yeah, so here how it works. I hope you enjoyed it, and hope you will enjoy my write-up. Sorry that this video is kind of cumbersome because I didn't have a lot of time, but write-up should be pretty well structured, and you can check it. Hope you like it. Thank you.